needs this kind of mechanical intervention is to remove these very, very highly toxic carbon monoxide that tends to collect in the basement. Okay? So today's focus will be on how the services, that is the mechanical part of doing the ventilation for the basement, will be done. So if you see the first slide, this is one of the student of the previous year, or maybe I don't know, some other year, has this thing. So if you see the what all things you need to show in the, hello,
We're not able to see the
can
screen. We're not able
you
to see
hear
the
me?
screen.
You're not able to see the screen. I'm not sharing the screen. Okay, my eyes.
Can you guys just leave and come back again? Is it the problem with everyone?
No, we can see.
No, I can.
Okay, so the people who can't see,
We can see.
yeah, there must be a lag, or just log out and come back in. We'll wait by the time.
I think even I have a severe major problem because generally, I mean, I did my class yesterday, I had no problem. But today, I don't think I'm able to share my screen at all. It's acting really weird.
Is everyone able to see the screen now?
Yeah, we can see.
Okay, we will continue, please. Thank you.
So today the main focus will be on the mechanical ventilation of the basements. Okay? And what are the things that you would be required when you do this? Okay? So if you see the first slide, can I keep on entering because there are some kind of animations here. So you will see that first thing that I require, and we talked last time, was you require ramps with a good turning radius that you see here. Okay, I would still suggest to be a little bit more because this is a little tight kind of a situation, especially when two cars are going on. Okay, you need to show a proper structure. So if you see the straight lines, those are the beam lines, but a column and a cap. Now that cap is nothing but a pile cap that is been planned for this foundation, and so you need to show that for the very simple fact that when you lay down your drainage pattern or the drainage for the basement, it should not come into or it should not barge into the pile cap. So those are the reasons why you need to show that. Anything that is structural like fire escapes, any other ducts that you have, needs to be shown here. Next. So the next slide will show, okay, my next slide, yeah. uh, just keep on pressing till all the things are there. So in the next slide, the same basement, but now you will see red line there. That is nothing but the drainage line. Okay. And at the end, where if you see the square, so if you see the detail part at the bottom, okay, the blue one where it is written a sump pit, कि मैं press करना slide kar slide, so you will get that. So you will see some pit, okay, and the red line, this thing, because it was not possible for you guys to understand in the larger scale. I have taken a zoom of it and put it here. So that is a sump pit. So there are two sump pits. One is on the extreme, in one is near the staircase and one is near the this thing, and then that has to be take sumped out. Okay, so there are two sump pits in this diagram. One I think is not colored. uh, Parking layout has to be shown, and depends, again you have to find out what is the kind of what are the kind of requirements for your site. You need to attach to the bylaws, find out the number of parking and then plan for it. And if you need to go for a larger basement, you will have to plan for it. And that's the reason why you will see that sometimes basements go as deep as 3 floors, because the parking requirement is there. And when you go down 3 floors, people generally don't use ramps, they would go for those car jacks, or you hoist the car up and down. So the or car lifts are there. So lot of or you have double parking. All these kind of new technology has come up because parking has become now a very overriding factor in planning. uh, and infrastructure planning, if you say parking problems are one of the big city's biggest problems, and that's the reason why most of the people are talking about going for public transportation, so that all these issues can be resolved automatically. Coming back to basement, so your parking layout, my staircases are there. Now, do you see those four dots? Keep on pressing. So you will see that there are these rooms on the extreme lower side pe. Just take a look at those. These are the some of the rooms. I'm not saying they are all. There are some of the rooms. So exhaust rooms, HVAC rooms, that is your AC plant room. There are a lot of names for this room, so don't get confused. I'm just going to name them. If you have your book and pencil, please take it down. HVAC is also known as AC plant room. Sometimes people call it as a chiller room. So don't get confused by these various terminology that you will come across. Meter rooms are planned below. Generator rooms are there. Transformer rooms, in case if it's a very large complex. Sometimes you need to house a transformer room where you can do the voltage up and down. So those kind of excuse me, guys. I think I have a problem with my throat today, so I'll have to take little breaks. uh, so yes, you have generator rooms.
Meenal,
Yes.
I have a doubt. So ideally, all these service rooms should be on external wall, or should it be like on the internal ones?
Okay. Good question. It ideally, I want it to be on the external facade, because it saves my cost. Simply because when I put it in the center, I need a very good ventilation for it. If you are ready to go an extra mile, an extra step, and provide a separate ventilation for it, I'm okay. Have it anywhere. No problem. Okay. But it saves my cost. I don't have to separate out. See, exhaust and plenum ka kaam hai कि it does the mechanical ventilation for those for that entire area. But what about the ventilation for those rooms? Okay, so there might be some pumps there. It could be the fan can create some kind of heating up. So who will ventilate that? So I need to have a separate ventilation for that system as well. If you are going to do give me that, go ahead, place it anywhere. I have no issues. Got it? Any other? So this question is clear.
Yes, yes, Meenal. Thank you.
Great. Okay. So you saw these number of rooms. As somebody asked me, this could be anywhere, provided you take that extra step. Okay. Next slide. Next slide, please. Hmm? So the next slide is actually talking about how do you go about placing your mechanical rooms. Okay, again, now there are various terminology. People will talk about it. Okay, there are no fixed things. It is known as mechanical rooms. They are known as fan rooms. They are known as exhaust plenum rooms. Okay, there are various ways people will talk about it. Don't get confused or give them a blank look. Okay, exhaust room and plenum room, as they say and as the name suggests, are exactly that. Exhaust will exhaust the stale and the used air from the basement. Plenum is provision of the fresh air. Now, many a time you will see that if the basements are smaller or parking is not such a big issue, parking is happening on site. It's not a big requirement. The only kind of requirement for the basement is having heavy duty services there, which I can manage with a small. In such a scenario, na, people will not go and do this massive kind of double mechanical ventilation. Okay, they will only go for one kind of a system. Say, I will provide exhaust there. Now, what happens when I provide an exhaust? The moment I provide exhaust, the entire area goes kind of in a negative zone, right? So, from the windows, from the ramp, automatically wind starts coming in and kind of aeration happens. And of course, you have fans and everything. So, it takes place. But remind you guys, this is only if it is small and there is no parking. The moment you say, I am providing the basement for the sole sake of giving parking, you have to go for exhaust and plenum, because as I said, exhaust is required to take away your monoxide on a very large scale, carbon monoxide, and then plenum is required because obviously when you give parking, the scale of the basement goes very high. Clear? Is this clear? Fine. So now if you see, uh, obviously if you see, the primary beams will be on a shorter span of the building, right? Now, if you see the thick two lines, okay, the exhaust ka red line and the plenum ka green line, okay. Now, exhaust is the, as I said, you will have a fan there, and plenum room will have a fan there. So you will have two fans, okay. Uh, Now, exhaust is going to suck the air in, plenum is going to force the air in. Hmm? Now, and so you have the same kind of setting. You will have primary ducts, and from there it will be secondary ducts. Obviously, primary will be more in thicker in section because it has to take the entire volume of the air that it has to throw to the basement, and then secondary will take its own volume and give it to each bay. And how will it give to each bay? There are these grills and diffusers, which you will also see in your split units that we have in our computer rooms, in your own homes. The grill that is situated outside your split unit is a grill. Okay, if you go to a restaurant and you see those grill kind of a thing on the top of the fall ceiling, are the diffusers. Generally, grills and diffusers look same. Okay, there's not much difference. Okay, uh, but we say it, the names are given different. Generally, grills are the devices that take the air back in. But diffusers are the one which gives the air out. Yani it throws the air into the space. This is only to differentiate the, when I do the drawing, people should not get a wrong idea. And so, but essentially they look same. Okay, they look same. And grills on a larger umbrella, I can say grills. Or on a larger thing, I can say I cannot use diffuser because the idea of diffuser is to throw away. Grill means grill. अभी अंदर हवा जा रहा है कि आ रहा है, that's not bothered. So please be aware of what I'm saying. These are the some of the terminologies, and this is how people get confused. Grills is a larger umbrella. Grill and diffuser are used for two different things. Grill is maintained for exhaust, while I take the entire the stale air out, while diffusers are generally for fresh air. Okay, in AC also, as well as in the mechanical ventilation as well. Okay. Uh, how would you then space this grills and diffusers? Obviously, they should not be very nearby, because what will happen is, if the two ducts are very nearby, if you see the central part of the drawing, the ducts are little. I don't know what is the scale of the drawing, and it must have approved because she has not changed it. So I guess it must be 3 meters. It can be little larger than 3 meters, but generally we do not keep it very close by, for the simple reason is air gets short circuited. What does this mean? That you plenum yani ki tumhara diffuser will throw the air, but the grill is sucking the air in. So everything happens at the ceiling level. The air never reaches down. There is no kind of infusion of fresh air inside the basement. So yes, there is an issue. That's the reason why I will space out my grills and diffusers at 3 meters center to center. Larger, it can happen. Try to avoid, ठीक है, 2.5 I will give you, but it actually takes away the energy from it. So generally 3 meters center to center, you should have your grills and this thing. ठीक है, next slide please.
Meenal, hello.
Yes.
So
Hello.
अगर जो एसी वाला डक्ट है वो अगर नीचे रखा जाए और एग्जॉस्ट वाला ऊपर रखा जाए तो will it not be efficient?
It can be. It can be efficient, but generally ऊपर नीचे आते ही नहीं. देखो ना तुम्हारा layout कैसा है. I will not want them together.
हाँ, that's what I am saying कि अगर जो एसी वाला डक्ट है
You see, it can be up and down. Distance should be 3 meter. Whether diagonal, so what we do is we generally take a radius. Okay.
हाँ.
Now the radius में अगर sphere बना दिया, so it will work the same way ना. Ideally, ऊपर है या नीचे है या साथ में है, 3 meters distance होना चाहिए. How you do it is problem. There is no problem. Getting it?
Okay, fine. Yeah.
And ideally, I will not want them one above the other. पूछो क्यों? It will reduce the height of the basement. Because already,
Oh.
guys, this is the basement. Huh? यानी कि it's the lowest part. That means it will have the thickest of the beams. Okay. Now, in such a scenario, you have primary beams which are like thick, okay, then you have your suppose by planning some problem, now if you see the primary duct is always the heaviest duct, okay, in size. Now if you see the primary beams and primary duct, they are aligned together, okay, ताकि वो parallel जाए.
Yeah.
Don't have and so getting it. So just imagine कि आपका primary duct is 600 but secondary is only 450. So I get a leeway of 150 ka thing, right? I don't have to put my entire duct under 600. You're getting my point? What I'm saying?
Yeah.
हाँ, तो इसीलिए so ideally we avoid as much as cross laying of the ducts. You can of course इसके ऊपर when you try to put your fire, when you try to put any other kind of services, they are all going to go into crisscross, but those are very small elements. Now when I'm talking about fire, and I'll be showing you that ahead, fire will be half inch ka line. That's not really big, you know, I can even hide it along the side of the duct. That's not an issue. So these are the things that you will have to keep in mind. Okay, any questions on this, guys, before we go ahead? Fine.
No, we can
So
proceed.
okay, great. So the next is showing you the ground floor plan and this. So when we do a basement, okay, as an architect, I need to talk to the client or talk to the contractor, and I need to give them an idea, okay, what is the relationship of my basement to the ground floor. Also, lot of things from the basement will open out on the ground floor. Via you will have to cut the slab or through the windows, I don't know, and we'll see those drawings ahead. But right now, just keep this in mind and see this. What I'm trying to show you is that you have a basement plan and then you see it in the red, that is your ground floor plan. Okay, the ground floor mein the structure is like this, but the red one is the position of the basement on that side, just below that one. And so you will see the extension on the lower part is not considered as the basement, because if you make that kind of a narrow basement, neither you can do parking nor you can put any house any services there unless it's a UG tank or something. Because the moment I put, suppose if I put my exhaust there unnecessary, I have to lengthen the size of my ducts. Okay, and coming to the size of the ducts, we will be doing that later on, but remember, see, these are mechanical systems. Okay, it has, when you say a fan is a mechanical device. It has certain strength and it can throw air only till that time. Okay, uh, if I say that, okay, my basement is like really long, okay, and I have my entire this thing is being worked on one fan, और वो 100 मीटर तक मेरा duct जा रहा है, probably at the end of it, oh, it will not have that kind of velocity or the sucking in power or throwing out power, and it will be useless and unnecessary waste of money and space because you have already built it and it's of no use. So you need to be aware that what are the limitations when you do the length of the ducts. Now, if you are going beyond this length, say I cannot go beyond 35 meters or 40 meters because ye mechanical hai, I'm not really taking care of the humidity and the comfort and the temperature. I am only seeing that I get fresh air. Not any other criteria is done. Okay. In such a scenario, I can go for the length and little bit of uncomfortable because people are not going to stay here. It is only for parking. Okay, as long as my carbon monoxide is taken care of, I'm happy. But if it is a used air, suppose you are doing it for a lab, because lab is creating these kind of toxic thing, suppose aisa kuch hai, okay, and you need to release that out, then, and also the people are working there in such a scenario, guys, all these things matter a lot, that what is the limitation. And for this you have engineers, okay, you and me as an architects are not capable of doing this kind of calculations. It's not in our syllabus and not in our context as well. So we just have to be aware of the limitation. And so when we plan, if your basement is very long, see to it that you have two plenum and two exhaust, because I can go 35 40 and then I stop. I will not allow you to go for 70 meters 80 meters, pointless sir. Hmm? Okay? Now somebody will say, but what if with the new technology there are great fans available? Great, go ahead. But you know what? When you have this kind of a throwing capacity, they make a lot of sound. Okay, now if the technology is giving you soundless fan, fantastic. Then we can go ahead. But right now, for the academic purpose, we will take 40 meters as the max. Kimaya, if you have anything to add, please go, Anna.
Yeah, I'm watching.
Yeah, if I forget anything and you wish to add a point, please go ahead. Don't even have to take my permission. So is this clear? This is the ground floor position with the basement, showing you how those two are related. Okay. This is another project by another student, okay, and this was the drawings are little not done well, but they were in the sense, sorry, they're pixelated, they were excellent. In fact, I think she scored highest. But just take a look at the detailing this person has done. Now, if you see, this is just a schematic footprint of the. So, if you see all the dotted, I mean, see the plane, that is a plinth footprint, and the gray part is your basement. But at the same time, she's trying to show what happens in the on the terrace as well. So your OHT, your toilet block are dark, your staircase block, everything that goes up. So it's a clear cut idea of what I'm going to see on a terrace, what am I going to see on the ground, and what am I going to see, and what all services that pops out of the basement. The clear cut idea of that this thing. Next. Hmm? So this one is talking about. So if you see, the drawing is little blurred because it was too detailed, and I could not take a this thing. Now, if you see, now this is your ground floor plan. Okay, she is showing you this as a ground floor. So this is how her layout is, and if you see those three circles, okay. Now those three circles are cut out in slabs. Now, if you go back, and I'll show you. Sorry, if you go ahead, I'll show you this. Can you go ahead a little bit? No, no, rehne de. Kimaya, forget it. I'll finish this, then I'll go ahead. So at the ground floor level, you see BMS room and meter room, right? You see the pink line, that is the rainwater harvesting lines that she's collecting for her site. Okay. She has toilets marked because as a cross. Okay. So the toilets are there. Right at the entrance, there are two fire escapes. Do you see a blue top side left and may you see a circle, and right next to it there is a blue square? Can you see that, guys? Where it is written cutouts in slab.
Yes,
Do you?
yes.
Yes, right. Now what is that? Do you know that?
Yeah.
It is a sump area at the basement level. She's just trying to highlight that. And then do you see, if I don't know whether it is possible to zoom, but then do you see a yellow dot? If you can't see on the this thing on the right hand side, do you see the same blue color ka box with a yellow thing at the top? Can you see that?
Yeah,
Yes.
yeah.
Right now, this yellow thing, that's a grease trap. So what she's doing is, basement may you have the drain pattern. From the drain, she's collecting to the sump is then with the help of the pump throwing the water out. But that water might have a tendency of oil, petrol, which, because you have massive parking there, so sometimes that leak happens, and then it is. So every, even at the parking at the parking, or even at the petrol pump, the drainage areas will have a grease trap there. So what she's doing is, the moment the water is thrown out, okay, it has to pass through the grease trap, collects it, and then she's throwing it into the gutter or wherever she has planned it. So this is how at the ground floor level the functioning of the basement and the ground floor is this thing. Now if you see these three circles, okay, they are the basically the, see, when we talked about mechanical ventilation, I said that they are the fan rooms. Okay, now fan room is not a magic, na. It takes air. What is fan doing? Oh, it takes air from one point and pushes out to the other point, barabar hai, via ducts. It's as simple as that. It is not creating air. Nobody is energy is constant. I cannot create anything, right? So it is just transporting air from outside to inside. Now, where it is getting that outside air from? Because up to basement, mein ho, you don't have any. And then somebody asked me that, what if it is in the center? Suppose you have it in the center, then you will have to take a duct out from that tiny window, that will the only thing that you will have. Okay, and from that you will have to take it up from the ground floor, you will have to come up, right? So somewhere you will have to cut and come up. Okay, these cutouts are those. So when I show you the basement of the same, please remember these 3 points, okay? They are like a triangle. So these are nothing but those cutout points, jise in a proper terminology, they are known as mushroom mushroom spouts or mushroom tar, okay? Lot of names are given, okay? Or a spout, कुछ भी आप नाम दे सकते हो. But mushroom tar are the basically what it is generally associated with, because the moment this duck comes out, okay, it needs to be protected. So generally they put a kind of a hip roof on it or a kind of a shaded part on it. That kind of looks like a mushroom popping out of the ground, okay? So then it's up to you that when it comes on the ground, what kind of element, what kind of elevational treatment you want to give. Do you want to hide it? Do you want to expose it? Do you want to make a statement out of it? Or do you just want to make it look like a sore thumb because you didn't think about it? It's all your call. Okay, so this is your, and then do you see drain at the start of ramp? So last time when I talked about basement, water being a major issue, okay, and I showed you that diagram where just before the ramp starts, you have to do those double drains and those double bumps so that my water is arrested right at the beginning. But then Bombay being Bombay, Mumbai being it, okay, with 2200 water pouring down in 4 months, okay, chances of it having a heavy rains on a few days is high. And then when this happens, that is where the drain at the start of the ramp is given. That's where this thing happens. Next.
Meena, there is a request. Can you just repeat the usage of the duct again, please?
Oh, sure. uh, so see guys, so I have a fan room, ठीक है, चलो हम plenum की बात करते हैं. Now plenum is taking a huge amount of air from outside, which is from your natural surrounding outside, and all it is doing it is taking that air, that volume of air, and pushing it in. बराबर है? Are we clear on this part? Yes, guys. Are we
Yes.
clear on this part? Okay.
Yes, yes.
Yeah.
To do this,
Yes.
very good. Now to do this, what will I have to do? अब मुझे इतना बड़ा duct जो है, because you saw those secondary ducts na, they are like huge length of it is being crossed, so the volume of air is going to be high. Now if I have to take that big chunk of volume in one shot, don't you think it I'm going to require, मैं ऐसा change का pipe का cutout तो नहीं देगा ना उधर. I will be giving a big amount of nice 2-3 feet, maybe even more, 1 meter, I don't know, depends on the calculation of the ducts which your consultant will give you. Based on that, that duct will have to come out at the ground floor from the natural air outside. It is going to suck that air in and then throw it into the basement and call itself a plenum room. Is that the job of a plenum room, right? Now to get that fresh air out, I need to come on the ground floor. Now there are two ways of doing it. ठीक है? Now if it is on the external wall, and if I have blessed enough size of the window, I can do one thing. I can take the duct out from my window. I will have to do a lot of turning and twisting, because pehle it will turn to go inside the window, then it will turn up and go outside. But then, or I can take it so once it comes outside the window, you are at the ground floor level. Now from the ground floor level, it is your choice whether you wish to attach it to the wall of the building and take it up, or you wish to take it ahead and push it at the boundary level, ताकि your building का elevation will be ठीक ठाक. It's your call. ठीक है? So that is one method of doing it. But suppose your plinth is only for 450. For whatever reason, you have constriction that I do not want to. Suppose that entire building is done for handicap and ramp का issue है, जगह नहीं है, and 450 भी high है, problem है. Okay, I'm just creating a scenario for you guys to understand. Now in that 450, the size of the beam is 600 because basement hai. Where will you get a window proper? Difficult hai na? So in such a scenario, there is no window. Imagine that. Now in such a scenario, you will have to cut your slab internally. Okay, so I have a plenum room. The slab of the plenum room at the top, the ceiling of it, not the slab, sorry. The ceiling, I will have to cut it, bring my duct in sorry, up at the ground floor level, and then push it out through a window or through the wall, and then take care of the elevation. Now you are getting it, what I'm saying that cutout is. And when I show you the basement plan, it will be clear. And then I have a few other drawings that will give you a very good idea of what I'm trying to say. But is this clear, or should I do this once again? I'm okay to do it once again. But this needs to be shown at the ground floor level, because this is a very, it creates, otherwise, I'll tell you one thing. Near our building, KRVI, you have Ecole Mondial. Now, if you go to the Ecole Mondial, you have a nice banquet hall, okay? But at the entrance of the banquet hall, you have this mushroom tower. And so they are doing a lot of elevational treatment, and they did all that, but it still looks as if it is not there. It's not required to be there, but it is needed there. Okay, it is needed there because that is the only way the basement of that Ecole Mondial can be taken care of. So now do you see what I'm trying to say? It is going to
Meena,
harm the elevation. Yes.
1 second. Just explain them 1 second. If you're tired, you want me to explain.
No. I can
Ah,
go on and on
okay.
and on. But
No, you said
before
you're
before I
throat
do
was
that,
bad.
can you go ahead so that they will get an idea what I'm trying to say? When they see the basement, they'll get an idea. Just remember these three position, guys. Then I'll come back to this again. See that you will get an idea what I'm.
Also, just go a little slower.
Okay. So once again, I'm going. So in the next slide, what you see is, no, this is sorry. This is the next slide is only showing you the sump position of the sump at the basement level. And now do you see that small yellow thing? That is a grease trap. Next one, Kimaya.
This is the next one, which is a sump pit. I'll just move on.
So this is again, so before I go ahead and I'll come back to this, don't worry, I'm not forgetting it. I'll come back to your cutouts. But since we are on this slide, let me finish this. So do you see the way the lines of the drainage are done? What did I say? Since this is in the raft slab, the criteria is I should have minimum length, so that the depth is, I do not have to go deep down and then again I have to pump it up. So my criteria is that my sump pit should not be at a great depth. Okay, so the way I will plan my drainage is I should keep it free of the pile cap. I should keep free of the I should keep free of any hindrance to the maintenance, and I should have minimum length to it so that my depth is controlled. Okay. The next one, but at this level, again, do you remember those cutouts? Do you see those three triangles at the triangle position? One is right at the sump ka jo hai. Do you see one cutout there? A cross, a box and a cross. There are three box and a
Yes.
cross in this drawing. Okay. Now in this, those are the ones that I am talking about. Now, if you see the top wala near the sump on the extreme left is your exhaust room. Now, what she has planned is, since hers was a C shape or U shape, whatever you call, uh, what she has planned is that she will give more exhaust so that plenum can, I mean, the little bit of push of the air, automatically the negative pressure will pull the air in. So what she has planned is she has two exhaust on either side, and at the bottom left, that crosses there, that is your plenum room. So this is a place where she's taking the air from outside and supplying it to the basement, while the other two sides are taking the exhaust and pushing it out. Now, if I go back to my the drawing which showed you the ground floor, do you see? Can you go back, Kimaya, once again? Sorry.
Is this the one? Meena, we can't hear you. The voice is cracking.
Now can you hear me?
Yes.
So you see a filter bed. Okay, then she's tried to show you the position of the UG at the bottom. Okay, it's not on the top but at the bottom. And you see a gray color ka box. Okay, that gray color ka box is opening onto your plinth level. Okay, and it is coming from the exhaust, so there is a cutout in the ceiling. She's bringing that entire, so it has to be done, so either you can do it in concrete or it can be done in a brick, and through that brick you will have your aluminum duct which is coming out, and then it is releasing the air outside. So now is this clear, guys?
Yeah.
Hello? Now is this
Yes.
clear what I'm trying to show you? So at the basement level, she had those
Yeah,
three,
yeah.
okay, two exhaust and one plenum. And if you correlate those three boxes, one with the ground floor, you have to cut them and come up, because she was not able to take it out through her windows because she did not have the high level of plinth. So in such a scenario, all she's doing is she's just cutting the slab, allowing the entire thing to come up, and then she's protecting on the top from वो सब उसने नहीं दिखाया है, that you will have to do as a detail for working drawing whenever you take a working drawing. So in seventh semester, you guys will not be doing working drawing. You have to show us the schematics. Okay, this is a schematic drawing. This is not a working drawing. The kind of detailing that you see here is a drawing from the previous year, which is what you guys will be doing. Okay, probably IDS will change, and your professors would have already told you what is an IDS studio. So probably this is not what you are going to do. You'll be sitting and actually designing a new one for your technology. But is this idea clear now? What is a cutout?
Yes.
Why do I need a cutout? Why is my
You know, do you
correlation?
have a section? It will be
I
much easier for them.
picture. I have a picture that will show you what I
So
mean.
you want to
So
show that to them? It's better.
yeah. So what I'll tell you now, you go at the back, but तेरे को बहुत पीछे जाना पड़ेगा.
Back के आगे.
पीछे पीछे पीछे. But this is actually the now only about 5-6 slides are only remaining.
एक second. Let's go back and show them so that it's easier for them.
No, sorry. तुझे आगे जाना पड़ेगा, darling. Sorry, sorry,
वही
sorry.
सोच रही
नहीं, I'm so sorry. देखो आगे जाना पड़ेगा. I am so sorry.
It's okay.
ठीक है? आगे जा, आगे जा. और
हाँ.
आगे जा.
आजा.
हाँ, see this. और आगे जा. हाँ, do you see this now cut out in the slab that I'm talking about? Huh? So you have a slab, you have a fan room at the bottom, which is written mechanical natural air supply plenum system. Now, this is what they are trying to show, that if you have a room above and you have to cut it, okay? What I am trying to tell you is, it's not the same diagram, but what I'm trying to tell you is, ki suppose if this was in the basement, can I have that window there? My question was that fresh air inlet jo likha hai, can I have that possibility at the ground floor, at the window level of the basement? Yes or no, guys?
No.
Yes, you can't have it, barabar, because you do not have the place for it. So probably you will have to cut the slab, bring the duct up, again then you cut through the wall, bring it out, and probably give the same window at the ground floor level. Okay. Now, when I say that, can you imagine a centrifugal fan? Now, I'm going to also tell you what are the various fans that are available. But centrifugal fan has a kind of a velocity that you can't stand in front of it, because the velocity is too much. It pulls things. Okay. So the other reason why I cannot have it at the window level of the basement is because wind के साथ it is going to pull all kind of dust inside. It will pull everything. I mean, किसी का बाजू में कुछ कचरा है, या if there is a dustbin lying outside, so everything will be pulled inside because the velocity is huge. The kind of power that thing it has a sucking in is like terrible. So in such a scenario, any which way I cannot have it out, and I need to bring it out, and I have to be at least 3 feet above my ground level. Okay, and position my duct in such a way, higher the better, but I'm giving you minimum as 3 feet. Okay, don't keep it at the ground level. Okay, Baba, at that level only I can have it. So at least have it at a window level where your normal window level of the ground floor is. so that I will not get in all the dust and mitti from outside. Otherwise, what is going to happen? Your entire cars that are going to be there inside are going to be shooted. I mean, it be covered with a layer of dust because plenum is getting in lots and lots of this thing. Okay, so do you understand this diagram a little bit? I unfortunately do not have a section. Neither those kids had, and neither it is there anywhere. So no, I don't have it. So Kimya, you'll have to go back.
Yeah, I'm just process.
Yeah. So now very good. We are almost finishing. So then we come to the, so everyone is clear with the sump, with clear with the cutouts in the slab. How do I get my air outside or release the air outside? Okay, because ultimately air has to come from outside. So that has to be done. Now, this is a very different system from your AC, which we will be, the next part of it is AC. AC में ground floor में air नहीं चाहिए मुझे. In the basement, I don't need air because there we have a different system. So it's a complete different setup. Okay. This place I need air because I am just doing, my only job is to replace this air. In AC, what we do is most of the air is returned back and the same air is thrown back. We don't change the air. Only 25% of the air is changed. So there is no issue of getting in air and throwing out air. While this is not the issue, I mean, this is a major issue here. I have to get air from outside and I have to throw the same air outside again because it is used up. Okay, so that is the main difference between mechanical and AC. So we finish with the sump. We finish with the kind of ducts and everything. Coming next slide, Kimaya, you will see that. The same how she has planned. So you again see the thickness. Now do you see this, this has a telescopic way of taking the major ducts. Okay, so what she has done is she's taken the main duct arising from the plenum. Okay, and then as it goes further, the secondary ducts as well as the primary ducts will go on reducing. Why will I want to have the same volume of air everywhere? समझ रहे हो ना आप? You're getting my point, or should I elaborate on this? Should I elaborate?
Yeah, you'll have to just talk about the pressure, no, Meenu? Maybe then they'll. Yeah.
So let's take it. Okay. We generally, by the way, guys, we generally don't calculate for exhaust because exhaust is something I'm not taking, I'm not providing anything. I'm just taking away. So it doesn't matter. I don't really have to think about proper velocity and proper draught and everything. I don't have to bother. It's just taking away. Jane do. But when I'm supplying it, I have to take care whether every nook and corner is supplied, whether it is supplied in the right quantity, air change ho raha hai ki nahi. All those things I will have to take care of. So supply is more important than your exhaust. Okay, especially in calculation of your ducts. So I will not go into the pink wala lines. Just concentrate on the green. That is your plenum duct. So let's. So you see the exhaust which is written in pink. We will take that duct. Okay, the green one, and you take the tip of that. Okay, now do you see a grid of structure there? Okay, so what we do is we make bays here. Okay, so every 4 columns will form one bay, and ideally we name the bay. So I will start. So obviously, how will you name the bay? You have already done your working drawing. So you have given the grid lines, na? A B C D 1 2 3 4. So based on those, or you name your own. आप अपना भी nomenclature लगा सकते हो. You can start from A1, A2, A3, A4, B1, B2, B3, B4. So something like that. Okay. So if I see the top area, suppose I name it as A1. The second bay, I will name it as A2. Now, generally, unless you have not planned well, but generally the grid remains the same. Okay, especially this has to be a, and we already talked about grid in the planning. Okay, that 8 by 8 meters is really important when I talk about basement. So I'm assuming the bays are same. Okay, so I'm saying A1, A2, then I am coming further where the car parking starts is my A3, and then the duct is having a kind of a turn and then becomes horizontal. That is my A4. So assume that I have A1, A2, A3, A4 as a bay. Now, obviously, the duct which is starting from the point where it is taking a turn, now that duct is actually housing the volume of all four, barabar hai? Then part of the duct, a part of the air is given to A4. Then it releases the air to A3. This all happens in matter of seconds, huh, guys? So, but I'm talking about volume. Then it gives the volume to A2 and finally to A1. So A1 का तो छोटा सा volume है ना, because it is only catering to that kind of a bay. But as it goes ahead, it starts accumulating these various volumes required by each bay. And that is how the calculation is done. And that is why, as you go further from the source of air, the duct size decreases. It helps me, first of all, costing. Lesser the material spent, lesser the smaller size, I mean the smaller the better costing, okay. And secondly, and which is primarily important to me as an architect, is it gives me more headroom. So why will I want to have the same kind of height and volume which is starting point to right till the end point? Ridiculous, right? That's the reason why you are seeing this telephonic or we call it, sorry, not telephone, telescopic kind of a layout for the duct. Are we clear what I'm trying to say? Are we clear, guys?
Yeah.
Who is not clear and would like me to repeat the entire thing again? I'm okay to repeat. This is a problem in just showing visual and actually having sitting in front, I mean, standing in front of you and showing with the help of my actions and pointing it out.
Meenal, we can't understand when you were saying A1, A2. Since you cannot point, we can't figure out where A1, A2,
Fine,
and
fine.
all
Very
the
good.
ways.
So, but did you understand what
Can
is a
you
K?
can you see the cursor when I'm moving it?
No.
You can't see the cursor.
ठीक है
If you
कोई बात
exit full screen, then we can see.
Is it?
probably. Can you
Now can you see?
now? Hello.
No, we can't. We
You
can't
can't see the
see
cursor.
the
Okay.
cursors.
No problem, guys. No problem. Okay. So, okay, I will take the other part. I'll take a smaller part. Okay. Acha, do you see plenum written there?
Yes.
Okay. Fine. Now, the first on the extreme left hand side of your screen, do you see the first green color ka duct happening there?
Yeah.
Not the horizontal one, the vertical one, vertical to plenum. Hmm? That is my secondary duct. ठीक है? That is my secondary duct. So what am I doing is, if you see the start point of the duct is very thick, then it reduces, and then finally it reduces. So it is reducing in, यहाँ पे कितने bay है? 1, 2, 3, 4. So there has to be reduction 4 times. ठीक है? She has done reduction 3 times, which is okay, because maybe that reduction was very small and it is not possible to do it. So one reduction will work. Now, why do I first of all understand why do I reduce my duct? As I said, to give me more head space, okay? Because more the depth, or even if it is more, if I lay it down, why will I want to then spend more money in having larger ducts? That is one reason. Okay. Second reason is, if I have larger ducts but lower volumes of the air, my pressure is lost. You're getting my point, guys? आपके पास एक बड़ा डिब्बा है और pressurized air डालनी है आपको, and you know that I require this much psi. Won't you have to fill it more number of air, more amount of air, more volume of air, instead of having a smaller dabba? Are we getting the picture, guys? No,
No.
guys. नहीं समझा? Say you, I
No.
require, I say I require, how do you say volume of air, Kimaya?
Let
मुझे
me just attempt this. Okay, guys, you need to understand. See, can you all imagine the layout of your basement? And it is in the grid because your columns are in the grid format. Okay. the moment each of the square that you see within the grid is a bay. Now, what Meenal is trying to tell you is that the plenum is at one corner of the basement. Now, plenum is something which is going to give you the fresh air from outside, which means that you have to make sure that each and every square within your grid is being provided with the fresh air. Okay. Now, as you go longer in the length, your pressure reduces to the farthest point. Do we all agree on this? Someone has to just say yes or no, then I'll move ahead. Okay.
Yes.
So that's what she's saying. So
Yeah.
to make sure that at the last grid, okay, the amount that you need to put into the last grid, if you have to make sure that amount is reached at last grid, you need to maintain pressure throughout the length of your duct. And that can be only done when you start reducing the duct. And that's why the telescopic form of the duct, when it starts moving away from the plenum. And
So,
also another, yeah, just let me finish and then you can ask
yeah.
questions.
No, I was
And
just
the
saying, said
other
pressure.
thing is,
I used the word PSI, that is pressure per square inch. Now go ahead.
basically because the amount that is required at the farthest block is less, that's why the size is also less, because the amount is only for one grid. But as you start moving towards the plenum room, you have to start adding the amount of air that you need to provide, because each bay you're trying to provide that air. So that's why when it starts leaving the plenum room, the duct, that's the thickest of the lot. Okay, and that's the primary duct. Now the primary duct can only go to 30 meters, not more than that. So sometimes your basements are much more larger, okay? So which means you shouldn't only rely on one plenum, you should have more than one plenum, okay? Another thing
Yeah.
is in this is basically you shouldn't, wherever your ducts are, whether it's exhaust or whether it's plenum, they shouldn't enter any of your mechanical rooms. Now in this drawing, it's entering your generator room. It shouldn't. Okay. Worst case scenario, if you can't avoid, then the supply one, which is the plenum, can still enter because it is providing the air. Now imagine a scenario if there is fire. The duct will catch up that fire and it will circulate it all over your basement. And within seconds, your basement will be on fire. So that's why you have to make sure that the ducts don't go anywhere through your mechanical rooms, which are much more susceptible to fire.
Clear?
Is it better?
Yes. Yes.
So when I say that, so if I take the first wala and if I say A1, A2, A3, A4, A1 being the farthest from the plenum, so what will happen to A2 wala jo duct hai na, that is now going to carry the volume for A2 plus A1. So obviously that duct will be bigger. Then you come to A3. So now A3 plus A2 plus A1 ka volume. That's why my A3 is bigger. And then finally A4, which is right next to the plenum room, is the thickest one because now it is carrying the volume for all the four rooms. Are we clear now? That's the reason why my volume goes on increasing as it comes towards the source, because I am having more volumes. Okay, because various bays have to be given equal number of that kind of volume. ठीक है? And while you are doing all this, you also have to take care of other services, as Kimaya said, that you can't allow it to enter into the other rooms because of. And suppose by chance, if you have to enter because there is no other option available, okay, then you at least don't give the diffuser or a grill there so that it can create issues there. So all those kind of precautions that needs to be taken care of. Are we clear on this part of the telescopic, the pressure, the bay, and the distribution? Are we clear? Can we go ahead? Now,
So regarding Itosha, regarding the fire, what I was trying to make a point. You want to say something?
Yeah, I was saying there is one plenum room, but there are two exhaust rooms. So
Yeah.
shouldn't be like there be an equal proportion of plenum rooms and exhaust rooms?
No. Other
Uh,
thing, no. See, other thing that you need to understand here is that you need to minimize your twists and turns that are happening. So most of your core, which is your staircases and lifts, sometimes they are the ones which you can't penetrate through. So because of which you are already twisting and turning. And also here the exhaust for the plenum, she's getting a direct, like, very clear cut primary duct. But for the exhaust, it's getting divided already.
Hmm.
And that's why she has provided two exhausts and the plenum. Then there is one plenum. So that's
okay.
why
Okay.
it's also very strategic that you have to place your plenums and exhaust. One thing is on your external walls, of course, and they should be also away from each other so that you can get this kind of a combing, drawing diagram, wherein you are not trying to cut across the other duct. Because sectionally also try and imagine the space, guys. This is not the only system that you have in place. You will have your AC duct, which will be going to your AHUs from your AC plant room. You'll have your electrical, you'll have your fire, which will come in. So I think as we progress ahead and will take AC and things like that, then we will explain you the whole concept of the reflected ceiling plan.
Okay.
Okay.
Another thing that I would like to add on to what Kimaya had just said is, it was a very right question when you said that plenum ek hai, exhaust do hai. But understand this, guys. If this was a case of AC, it is a strong no, because I need to balance the air. What happens in AC, as I just said in a previous some time back, is that in AC, all I'm doing is rotating the same air. I take it back, I refresh it and push it back, okay? While only 25% of external air is added to it. But doesn't happen so here. And also the second factor is, I am not taking care of the nitty gritties of the taking care of the kind of air that I'm providing, because I'm not providing this air for sustenance. It is only for cleaning the general ventilation purpose, okay? So in such a scenario, there are no questions about giving me X amount of air so that I can remove X amount of air out. No in and out ratio. In fact, यहाँ पे it will work better if there is a little pressure difference. The moment there is a pressure difference, air will tend to flow, especially when the air is in velocity and pressure. Air will tend to flow in that area, and you will automatically, without even providing a duct there, the flow of the air will take care of that. So in this scenario, it is the pressure differential that will act. So if you have two exhaust, the movement of the air, because now the ventilation is automatically, it's negative. So yes, from the not only the exhaust, the plenum, but also your say you have windows, you have ramps. From there also the air will, you will feel the air coming in. So because of that equation not needing to be balanced, I can have this. I cannot have this in AC. Are we clear on this point? What I'm trying to say?
Yes.
Yeah.
Yes.
Cool. So now we go. So this is the what ideally your basement ka ventilation part should be. Okay. So you should have two rooms. Depends two rooms as and when your need be. Okay. As I said, if the pressure difference can move my air, I will try to cut down my cost and my maintenance and my space everywhere. So depending on the size, the requirement, and the program of your building, you will go for this kind of a system. But I forgot to mention one part, and that is the exhaust. In exhaust, we are talking about carbon monoxide. Now, when I'm talking about carbon monoxide, monoxide do not tend to rise up because it is heavier. It tends to settle down. Now, आपके exhaust duct are going to run along your ceiling, and your carbon monoxide is lying at the base. Now the exhaust will not have that kind of power to pull all those layer of fumes of carbon monoxide up. So what you will have to do is, at strategic point where there is parking only, you don't have to go around doing this everywhere, but where there is parking, basically, because understand guys, monoxide is very heavy. It tends to it tends to settle down. Okay. So what you need to do is strategically where you have the car parking, between two parking, between three parking, okay, you need to take down. So you imagine you have a secondary exhaust का एक तुम्हारा duct ऊपर से जा रहा है, ठीक है, and you have a column. तो वो कॉलम से आपको उसमें एक ब्रांच देके आपको वो डक्ट को नीचे लाना है on the column, okay, and you will have to give a spout with a kind of a jali there, so that while I'm sucking the air in, at least it will remove the, suppose there are papers lying there, किसी ने cigarette डाला हुआ है और वो भी जलता हुआ, I don't want my duct to be on fire. So everything will be protected by giving that jali. So when I bring that chute of exhaust duct down along the column or wall and point it out where नीचे से वो सारा carbon monoxide ले जाए, I also have to take the precaution that people can be careless in the basement. वो जलती हुई cigarette डाल देंगे, paper पड़ा होगा, God knows what it will be. I need to that should not enter my exhaust and get it stuck somewhere and then becomes a cleaning issue. So ideally at the end of the duct there will be a jali, okay, which can be cleaned, taken out, cleaned, and then fitted in again, okay, and then you will allow the carbon monoxide to take it up. And this has to be done at between every 2 to 3 cars, okay, depending on where the availability of the column is. But even if you give between 3 cars at least one spout that is coming down, which is it's good enough. Okay, are we clear what I'm trying to say?
Yes.
So that is an extra part of exhaust that needs to be done, and it's need to be shown. So now if you see the, take the pink line, the first pink line on the left hand side, first pink line, okay, and now do you see that where she has shown the dark point on the line, there is also a thin line which is going and showing to the column. Do you see that on the screen? First pink line on the left hand side, okay, do you see the dots on the pink line? Yes or no, guys?
Yeah.
Yes.
Now usi dot se ek patla sa, very faded, actually that should also be colored. I think she has forgotten to color it, but do you see the pink line which is going towards the column?
Yes.
Yes,
It's
it's very
very faint.
faded, faded, but it is there. That is nothing but she's trying to show that these are the places where the, because you see there is no other exhaust. That is the only exhaust which can pull the monoxide from those 1, 2, 3, 4, 5, 6 cars there. And
So
how will she take the spark?
is it like a
Yes,
point where the air is getting in and
yes. It is a point where the air is getting in and taken up to the ceiling, and then finally to the exhaust room, and finally to the outside air.
oh,
Okay. Are we clear on this? So what she's doing is she's taking it to the nearest column as an extra thing. So at the ceiling level, I will see that mera secondary duct to ja raha hai सीधा सीधा, but where every column is happening, I see one small horizontal thing, and then that horizontal turns and comes along the column, and at the base you will see that there is a jali. Okay, now in some points people turn it a little bit and then provide a jali, but वो turning में क्या होता है, कभी कभी चलने में दिक्कत होती है, people don't see the turn at the bottom, and so people hurt their feet while walking. So now what they do is they just leave it, but at the base they will give the jali, and it is not touching the ground. It is not touching the ground. If it is touching the ground, हवा कैसे आएगा? You are blocking it. So it is like about 150 centimeters, not 150 centimeter, 150 to 200 above the ground level. It is stopped at the column. Column में वो clips लगा के, just as you use the clips for your waste pipes and soil pipes, similarly the ducts are clipped to the column, okay, and it runs all the way down. About 200 it stops from the ground, okay, and from there the carbon monoxide can be taken up to the exhaust room and then finally out of the basement. Are we clear? So this is how you will have to show in the drawing as well. Where are those spouts? That is happening, because I don't need those spouts say somewhere near generator room. or say somewhere near toilets. If you have toilets, ideally you should not have toilets, but hey chalo, to I don't need it there. Okay, only where main car parking is there and where my car is zooming out, I will need that. Are we clear on this? So we finish mechanical with this. Then I can go and do the fire part and then finally the components and we finish. Hmm? So the next slide is talking about fire. Fire we have done last time. So I'm not really going to go into it, but we did not do the drawing part of it. So this is what I'm trying to show you. So do you see a thick line here and a thick line on the left and on the right hand side? I have tried to zoom in a part of the this thing. So if you see a thick line, okay, and then you see a small thing that is happening in a small duct like area. Can you see that, guys? Can you see
Yeah.
that, guys?
Yes.
You see a small
Yes.
duct area, इसमें से एक छोटा सा लाइन आता है and then you see a thick vertical line. Okay, now that is my primary line. Okay, I can also do this, that small thick line become my primary and then this becomes my secondary and then the last point can become tertiary. The choice is yours. You can do it this way or you can do it that way. Ideally I would like to go gradually down, because imagine a primary is like 3-inch line, okay, while your secondary is 1.5, but tertiary have to be half inch, no more no less. Okay, so in such a scenario, or half inch रहता है या 3/4 inch रहता है, whatever. So so in such a scenario, plugging in 3/4 inch to a 3 inch is going to be too much. So I would like to step down the pressure so that it can be equally distributed, and then you put your tertiary lines in such a way that your sprinkler covers a 3 meter ka radius. Hmm? So you just take a point and take a 3 meter, then on that tangent of it, or another 3 meters, and you put. So that is how you will have your sprinklers placed. Okay, center to center distance between the two sprinklers is also 3 meters. Clear, guys? This is how your. Now do you see the legend here? So there is something called as CO2 panels. Do you see a CO2 panel near that exhaust का duct? कटआउट वाला जो हमने इतना बड़ा डिस्कशन किया, उसके बाजू में एक छोटा सा वेरी लाइट में दिख रहा है आपको CO2 पैनल. कैन यू सी दैट? If you are not able to see it,
Yes.
fine, let me tell you what is CO2 panel. So as Kimaya rightly said, first of all, we do not give any kind of plenum systems to these rooms. It's a separate system that you give, because I cannot afford to have the exhaust attached to this, but I still need to exhaust air from this. So वो एक separate system आपको set करनी है. Now coming to the fire, I also cannot give fire sprinkler into this rooms. In all my M&E, that is mechanical and electrical rooms, if I put water, okay, short circuit is the first thing that will kill a man. So I have to avoid water getting in. I cannot afford to give sprinklers in those rooms. So what will I have to give as a fighting element? My CO2 panels, which is nothing but a box with a fusible link as an opening. So what happens is, suppose there is a fire there and the temperature of the room rises. Okay, now the fusible link is a material which has a certain tolerance for temperature beyond which it will snap or it will melt. Now when that happens, it reaches beyond that temperature and it melts. What happens is the lid opens from the box and the CO2 powder gets sprinkled in the room. Okay, and that's how the fire can be subsided or temporarily can be controlled. Okay, so placing CO2 panel is very strategic. If you know that this is a multi kind of room, sorry, a room where you have multiple kind of equipments, you need to place your CO2 over each elements, over each machines, so that every machine, suppose if tomorrow it takes fire or one of them catches fire, at least ऊपर वाला टूटेगा और उसी मशीन पे गिरेगा, not कि बाजू में. So that has to be planned, that has to be actually talked to your and in fact for this also you have consultants, because when you show your drawings for BMC, there is another kind of yes required from your NOC, required from the fire chief officer, CFO, chief officer of fire. So they will be telling you this, suggesting you this, so obviously that is taken care of. Wet riser pipe and a sprinkler pipe are two different systems that we studied last time. They cannot be combined. The reason is sprinkler requires less pressure while wet riser requires huge pressure. Yes, yes, a question?
No, I think the mic has just got unmuted, and that's why you can see the back. Hear the back.
To show me where are these sprinkler pipes as in plan. Okay, एक दो circle दिखते हैं. But now you see guys, you have to understand from this drawing. You are trying to talk about services to your faculty, and obviously if you see the sizes of the pipes, you have to exaggerate it little bit, and your presentation has to be like kadak. Even if you're going little out of scale, you can write there. Services are only indicative. They are only schematic. Nothing is to scale. You can't show anything on scale here. Can you show half inch in 200 ka scale, 500? It will not even be a line. So you have to go out of scale and be dark, bold, and use it so that it's very distinctly seen. Hmm? Uh, so you need to show me these two pipes, and those two pipes, if you see, is in that same place from where that small line is coming to the main line. ठीक है? So you see those one blue color ka pipe and one red color ka pipe. So the blue color is standing for sprinkler and wet riser. Then you have to show illuminated signages everywhere. Where are you planning to put it? Okay. So all your exits, all your doors, your ramps, you need to tell them, but this is where you have to run for. Hose reels, the position of hose reels. Hose reel is generally in a building is generally on the wet riser ka tumhara hydrant rahega. Okay. The hose reel will be there. So I cannot say hose reel independently. It will always be accompanied with a hydrant. Then I have CO2 extinguishers. So along with CO2 panel, I will also have to give CO2 extinguishers in all the rooms. Now the question here is it's very funny, but I see uh, drawing mein, when I see the drawings, okay, everyone of all the services faculty, okay, when we see the drawings come to us, these all things, tumhara sand buckets, your signages, sometimes signages, but tumhara ye CO2 extinguishers, दरवाजा खोलो, at the far end of the room is my sand buckets. क्या करूंगी मैं उसका, बताओ मुझे आप. फायर तो अंदर लग चुकी है. Am I going to cross the fire and go and take the sand buckets and then extinguish the fire? It's stupidity. All these things should be just outside the door, so that when I enter the danger zone, I am equipped. I don't have to go inside and then equip myself. I'll die. So so you need to be very strategic and sensitive when you place these dikta chota hai, but it creates big impact. Okay. Fire sand buckets again. Ideally you would keep this ideally you would keep this right outside every door, mechanical and electrical ka thing. Okay, then you have smoke detectors, you have heat detectors. Again, heat detectors, you will there is always this debate, why should we put heat detectors all over the basement? But sometimes what happens is people don't run the fans, or the fans have maintenance ke liye gaya hai, and there is no ventilation there, and by chance if there is a kind of a heat build up and there is a fire there, so this kind of an extra precaution is needed, or rather advisable in areas where people are not there to take care of you or of the building. So yes, you require heat detectors and smoke detectors, but ideally people don't use heat detectors all over. Okay, in academics we do that. Okay, we do that, but in real life people use heat detectors in places of all M&E rooms, smoke and heat detectors, because sometimes machine might be heated up, okay, and it requires cooling off. The heat detector can really tell me all this. Okay, it will not give off fire, it will not give off smoke, but it will heat up, and that heat can build up in it, which can lead to serious accidents, and heat detectors detects this. So before the fire takes place, I am aware and can take care of. Any questions on this, guys?
No.
No, fire is clear, but these are all things you will have to show in your basement. You did not do any kind of drawings in your third year, even though the portion of fire was there. So this is an opportunity for you to work out fire. Uh, in a very great detail. Okay, I have no I mean, I had the drawing, but it was only for that drawing. I did not feel like putting it on this. Ideally the same pipe will take, or you will have to show the UG tank will be connected to the site hydrant. That also you have to show in your drawings. Hmm? So a hydrant will go up through that same cutout. It is taken on the ground floor outside, or you can connect it directly from the UG as per your need. Okay, next. Quickly, there are some few components that I just want you to go through. So what are the fans? uh, what are the fans available? So there are four kinds of fans. Okay, you and so these are some of the things that you require. Separate rooms for exhaust, we saw that. You require fans, you require filters. Now filter I did not talk about, because we are going to talk about filters in great detail when we talk about AC. But a similar kind of a filter can happen here. As I said, sometimes you require mechanical ventilation for a space like, say, laboratory. Now in a laboratory, when I'm throwing this air inside, I will not throw, as it is, it's a laboratory, it requires kind of a very very distinguished kind of atmosphere. So then I will use filter before I release the air inside. Hmm? It will be the normal fresh air, no chilling, no heating up, kuch nahi. The normal air which is going inside the room, but you can have filters. Now if you really are looking for a great kind of a five-star kind of a treatment, and you want your Lamborghinis and Mercedes to be protected, people apply filters even in the basement, so that the cars will be not having any kind of dust problem. So yes, you can go for filters. Then you have ducts, and you finally we had diffusers and grills. We have talked about this. Let's just do a little talk on how these kind of fans are there. Generally for a large basements, we go for centrifugal fans. They are the toughest, largest, biggest and more strongest. Okay, but in small areas you can go for the other three also. Quickly I'll just tell you how they look, why they look the way they are. Okay, next. The next is just showing you the diagrams of how they look, what are the kind of spaces you will require. So that's how my cross flow or tangential fans look. Okay, kind of air rotates out. You have small space, but you want to keep them in multiple areas. Okay, but with one supply duct, you can go for this. Okay, sometimes now these are the fans that can help you within the duct. Now you say I have 70 meters. मैंने आपको पहले ही बोला कि I cannot take my duct 70 meters. But suppose if I have to take that far and I don't want to put more fan का पैसा, that huge centrifugal fan setup, so I can have within my duct this kind of a booster, like you have a booster pump in fire. This kind of helps in boosting your air ahead. Okay, not a very good solution, but it's a kind of a compromise on costing. Okay, then you have propeller fans. Freestanding bhi hai, or you can have it like an exhaust, what we have in our toilets, kind of a thing. Okay, so do you see that bend where you say that mesh is shown? That is what I'm talking about for all the ducts that release out. You need to have meshes at the end, so that I will not get. Imagine the air is being sucked and poor pigeon is flying in front of it. वो भी जाएगा अंदर. So I need that kind of precaution. These are the ways my propeller fan can look at the below, so I can have a nice look. It looks like a normal grill, लगता है AC है, but it's nothing but a propeller fan. Okay, so these are the various ways my and this is a typical way a car exhaust will be looking, or my bathroom exhaust will be looking. Next, the next one is talking about axial fan. This is again a very powerful fan, but in a small area, and this can be used very well in the ducts. Okay, it runs the air axially, so it pushes the air ahead. Okay, um, centrifugal fans, as I said, they are huge. And so do you see in the right hand side wala this thing, do you see that kind of a circular thing, and then one thing spouts out? That is where your spout is going to happen, and that is a big in size, to which you will attach your plenum ka your primary duct that will be taking the air in or out, whatever. Okay, so this is how you will be utilizing your fans. Next, the next one is talking about uh, cost saving. Suspended ceiling act as a duct. It can be acted. मुझे duct लगाना ही नहीं है. I don't want to put duct and waste all that money in aluminium and then fitting the two different size of the duct and then labor and all that kind of thing. And I want a very quick kind of a solution. If it is a small area, I can do the one which is on the top, okay, which is saying that I just allow the duct to come in inside, okay, and the entire ceiling which is perforated can be worked very well as a. Now the question here is, ceiling will have dirt. Generally the question is dirt आएगा कहाँ से? But we have seen the things like कि cupboard में भी dust रहता है, even though the cupboards are closed. So if you have that kind of an issue, then you have the problem of this having a little dirty air. So generally this is not a very good option. Cost cutting never really helps anyone, okay, and this is really when you have like really just need to clean, give air without any thought to the use, only then go for this option. Otherwise the option is what is given below. Now this is actually showing you a typical kind of a auditorium ka section. So obviously this is what I am talking about is a proper AC kind of a thing. But forget that this is an auditorium and this is how the duct is going to happen for your normal ventilation. Then you have your extract grill, suspended ceiling, duct work is happening. Now do you see the duct work is increasing again, guys? Do you see that? Hello?
Yeah. Yes.
Yeah.
Yeah, so this is called as telescopic. Same thing. So the where you see that a vertical kind of a putty which is saying flexible link, okay, that उसके बाद वाला जो तुम्हारा duct है, it is taking the maximum volume क्योंकि वो बे दो बे के लिए volume use कर रहा है. Then it further branches out and then that provides only for one bay. So it's how the duct size goes on reducing as it goes away from the source. And then you have axial flow fan. As I said, if you have a very small area and you need to have this kind of a thing, then you would go for axial flow, very small, sleek, can fit in a window wall. So this kind of thing can happen. Next, I already showed you this slide where I am talking about this, where you have mechanical, mechanical. Mechanical and natural air supply, but only where you have plenum system working. Okay, so where you have only as a fresh air supply, exhaust automatically is pushed out, okay, by via doors hai, via windows hai, via any kind of outlets that are there, ventilators, whatever. Okay, so this is for very small areas. Ideally for basements you need to go for a higher one, because as I said, basements especially if used for parking, you don't even think about only giving plenum. It's a disaster. So go for a proper neat kind of a ventilation system. And the last diagram that is at the bottom is just showing you a plan in which you will have on one side you can show the kind of fresh air, and the other side is the extract, that is the exhaust. Clear? This is how the layout can happen. Now if this is a very tiny room that they are showing, and we have already seen the huge basements and the kind of bay and kind of thing that is required, so that I've already shown you. This is just the basic layout. Any questions with this? We end this. We finished with the basement, we finished with the mechanical ventilation. Okay, one small part is remaining, that is calculation. Now that I think we will debate between ourselves, Kimaya and myself, whether we need to go into those kind of details. And then if the thing is, if the need be, I will take that part of calculation later on. ठीक है? Are we clear? Any doubts? Any questions?
Nothing. Nothing.
Nothing. Either I was very clear or not clear at all. But anyways, you asked a lot of doubts on me. Yes, Kimaya.
We should do the calculations when they are ready to, matlab in the studio, so that then they
So
can,
we
implement those calculations in
अभी
their
करेंगे
drawing.
तो भूल जाएंगे.
And it's also
ठीक है.
difficult, no, for them, like, because we can't use the board and things like that.
I
If you
know.
want, we can still attempt and see. I think Nihar has a question.
हाँ बोलो
Nihar, please
निहार.
ask.
Yeah, so we have exhausts and all. So if we have two exhausts, so it automatically reduces the air into the basement. So what if
Yes.
we don't have plenums and we have very good ventilation systems? So
Hmm.
so do we really need a plenum?
Good, good question. So as I said, it depends on the use and the function. Now, if you have a lot of openings available, say you have a nice kind of a nice kind of basement where I showed you that, right, where you have this nice kind of a courtyard happening, and then you have a big window and a door that can lead inside. But again, it's a deep kind of a thing. So what I'll do is at the end I will give exhaust. Automatically, it will pull the fresh air in. But if it is for the small thing, you are getting my point, Nihar. That's why I keep repeating this point. If it is a small basement where my one parking is there and probably it's for a house, okay, for a, or maybe even if my basement is 10 by 20, I can go for one system. When my basement crosses like 20, 30 meters by 40 meters, where I'm housing some 20, 30 cars, plus I'm having heavy duty AC plant rooms, okay, plus boiler rooms, laundry rooms. अभी तो हमने सिर्फ basic किया है guys. When we take advanced services, like hospitals and many other things in fifth final year, you will have awesome kind of lineary of kind of services rooms there. So you will have laundry, boiler, AC plant rooms, okay, your BMS rooms, fire pump rooms, what not you will have there. Now, in such a scenario, with such kind of heat built up, with such kind of parking layout, with and also people working in these rooms, one system is always inefficient because आप exhaust तो कर लोगे. What if outside, and can you always depend on the external air? What if there is no? Sometimes you see a dead outside. There is no air outside. तब क्या करोगे आप? People will be suffocating inside. So we automatically provide air by some kind of mechanical means. Worst come worst, at least give eggshell fans there, which will pull air from whatever little pockets it is available from and push it inside the basements. But if it is a small basement, as I explained, you can either give only a plenum or you can give only an exhaust. Not a problem. Any other questions, guys? Are we done?
No.
Yes. Had a question? Yes.
Should I stop recording there?
Should we stop?
Is everyone good?
Yeah.
Yeah.
Yes,